So my name is Farhan Zaman. I'm speaking from the capital city of the exotic land of Bangladesh, which is Dhaka. Right now it's actually 3:30 here. So I would say good afternoon to all of you. At the beginning, I would like to express my gratitude towards Professor Kurd and the rest of the authority of MLNLP, who have allowed us the opportunity to be present, to be a part of this excellent conference, which is a big opportunity for us since this is my first conference in the world of science. So uh, I would like to tell you a story of how this prediction of vaccine side effect using deep learning actually came about. So the motivation behind this research was since me, Siam, and Zulker, we are from class of 2020. So as you all know, the class of 2020 actually had to go through a lot of difficulties since the pandemic had hit us really unexpectedly. We weren't prepared for it, and we, as all of us had expected, after graduation, you will do this, you will do that. For example, if I talk about myself, I wanted to go on a tour, on an India tour with some of my friends and cousins, but that did not happen. Then I had to look for a job. And as you know, the pandemic had hit the economy of the country really hard. So looking for jobs and everything was really difficult. So at that time, me and Siam, we were talking about what can we do, especially because since 2019, I have gathered some knowledge regarding deep learning. And me and Siam, we were discussing whether we can use our knowledge for any sort of research or any sort of doing, because if you have a knowledge and if you don't do anything with it, I don't think it's useful. It will rather be futile. So me and Siam, we were discussing. So at that time, that was probably the end of almost the end of 2020. So at that time, what happened was people were talking about vaccines, like vaccines are coming. Some vaccines such as AstraZeneca, Pfizer, Moderna, they were like almost there. People were talking about it. There were a lot of speculations regarding how safe the vaccines will be, whether so there were some funny speculations as well. Some people were saying the government will inject us with microchips and they will try to control us, they will monitor everything, these and that. And there were also some speculations regarding whether this will be safe, like for some people who have diabetes, for heart disease, they might not be able to inject these, so they will be at a higher risk. And if they inject these, if they get administered, these vaccines might have diverse effect. So that's why I discussed with Siam and our friend Zulker that where if is there any way we can actually do something regarding this vaccination, regarding what is about to happen. So then me and Zulker, after doing some after having several meetings, we decided, yes, once people start getting vaccinated, let's try to gather some data and let's see whether we can do anything with this data. So once the vaccination started, we wanted to gather data, which was really difficult for us. It was very difficult for us because during that time, as you know, travel restrictions were there, then quarantine was there, lockdown was there, everything was there. So it was very difficult for us. But Zulkar somehow managed, I don't know how, but he was really into this and he managed us one day of appointment at this hospital, which is the gastrology hospital at Mohakhali, Dhaka. Unfortunately, at that time, one of our apartment members in my apartment in fifth floor, this person got COVID positive. As a result, everyone in the apartment, we could not get out of the apartment. The entire apartment was under strict lockdown. And then we had to cancel that appointment. Then later on, we took another appointment. And after that appointment, we also had to cancel that appointment because Zulker got COVID infected. Then for the third time, we took another appointment. This time, finally, successfully, we were able to go there. We collected around 150 data. When we started collecting the data, we were trying to be as specific as possible. We were asking several questions, like, for example, we were asking people whether they have diabetes or not. If they have diabetes, what sort of diabetes is that? Is it a type 1 diabetes or is it a type 2 diabetes? However, the thing that we realize is that most of the people aren't really aware of what sort of diabetes they have. Is it a type 1 diabetes or a type 2 diabetes? They don't know. They just said, yeah, we have diabetes or something like that. No, I don't have diabetes. Then we ask them if they have hypertension or low blood pressure or what sort of problem they have. They were also very reluctant to relay this information to us, and some were feeling insecure. So as a result, what we realized that let's make a more generalized data. Let's create a generalized data. Let's just ask them the simple questions which they can answer. Like, do you have diabetes? Yes or no? Yes, we have. No, we don't have. Something like this. So we collected around 150 data. Based on those, we tried creating the model. Once we're done collecting the data, we started looking at what can be done using those data. How can we make sure that people are benefited? So that's why we started doing the background studies. In the background studies, what we have noticed is that there were very unique approaches regarding vaccines. For example, the effect of vaccination, decision in disease modeling through simulations, and global analysis of epidemic model with nonlinear vaccination rate. These are like very unique programs. However, unfortunately, none of them actually had anything to do with deep learning or machine learning. So we thought, yes, since this is the thing that we wanted to do, we wanted to incorporate machine learning or deep learning into this. I think this would be a good place for us to utilize this data, to utilize whatever we have at hand. So the next task was to actually create a model, and we call this the vaccine model. So we have the data, we filtered the data according to our needs. The filtration process is not something very complex or complicated. We just tried to accumulate the columns of the data that we think we can incorporate into the machine learning process. So then processing and the model trainings, the different models, there were, as you know, there are different models, the machine learning models, deep learning models, and choosing the right model is actually difficult because we don't know what model would give us the proper answer or a higher efficiency. So Zulker and Siam, they were really concerned regarding the efficiency. But then I said, look, man, this is the first time we're doing something like this. So I don't think efficiency is really important here. It's the idea, it's the thing that we're trying to present. We're trying to bring something new. Uh, there will be people who will be working on this, and the efficiency of this research will increase a lot in the future, in the upcoming future. So right now, I guess it's better if we just focus on the idea, if we try to furnish our idea as much as possible. So after that, what we realize, it would be better if we use recurrent neural networks, since most of the convolutional neural networks are used for visualization and image processing, whereas recurrent neural networks are something that can be used in particular aspects such as this. As we know, there are a lot of recurrent neural network models. However, we decided to go with LSTM and GRU. So LSTM was a fantastic model, and thanks to Keras and TensorFlow, creating or building these models have become very easy for us. We created this model, although at the very beginning we weren't sure regarding the activations, this and that. We figured that out throughout the process by trial and error method. There were different models, and we had to eliminate them in order to find the one that had the maximum efficiency, the one that gave us the maximum result, the desired result. So after that, we went to GRU, and we wanted to compare what is the difference between the LSTM and GRU in terms of efficiency. And later on, we realized, okay, it's time maybe we could do something simpler, So logistic regression, that's a little simpler than LSTM or GRU. So we decided, yeah, let's try that. Why not? Why don't we try something like this? Logistic regression would be nice for this. And we wanted to ensure proper comparison. so that valid comparison can be drawn. And that's why we made all the models having 250 epochs each. So all of the models, LSTM, GRU, logistic regression, they all had 250 epochs. Then at the end, we came up with this result. The GRU, that model had the highest amount of efficiency, which was 83%. LSTM had 79%, and logistic regression had 73%. And we were pretty satisfied with the GRU one, and that's why we decided to conclude that yes, for this purpose, for such purpose, GRU is the model that we would like to go with. This has the most accuracy. And as you can see from the graphs that we got, the graphs are well explained, I guess, in the paper. If it would be very, we would be really glad if you go through our paper. That would mean a lot to us. So then what basically happened was we decided, okay, so since that we're done with this, the first part of this, is there any way we could revise what we have? So we decided to redefine the model. So the first models were very simple, the just GRU, LSTM, logistic regression. So now what me and Siam we're trying to do is we're trying to find a complex model which has both GRU, maybe LSTM as well, maybe something a part of CNN. So we're trying to figure out, we're still in the figuring out process. We're figuring out what model can bring us a higher accuracy, and we're also trying to achieve more data. We're communicating with the people, the 150 people with whom we have communicated previously. We made them calls and we tried gathering more data. For example, at the very beginning, the vaccine was very generalized. For example, we did not know, now we know that it was AstraZeneca, but at the very beginning, we did not know what vaccines they were being administered. So now we're like, okay, let's focus on the vaccines as well, whether they're being administered AstraZeneca, whether it's Pfizer, whether it's Moderna. So maybe it will be more specific, more specified, and we would be able to achieve a more specific answer rather than a generic answer. So that's what we're trying to include, and we're trying to include more features such as the other diseases they have. For example, diabetes, heart conditions, these are not the only disease that people suffer from. So we're trying to find out whether there are other problems, other conditions, health conditions that can be detected. So we also consulted a few doctors. We have some doctors in our team right now. So they are advising us. We're really grateful to them for giving us their valuable time. So they have been really helping us to gather the data. And we are trying to compare the data which we will have pretty soon with the ones that we have already. And we're also trying to, since a large number of the population have got the vaccine administered so far, which was not the case back then. So we are also trying to gather a larger data set. And hopefully with these, we will be able to achieve a better result for the upcoming future. Thank you so much.